Hello friends, now we have to solve the problems on the pentagonal lemmas when they are resting on horizontal plane. Now consider a problem. A pentagonal lemma of side 25 mm is resting on HP with one of its sides such that its surface is inclined at 40 degrees to HP. Draw the projections of the lamina when the resting side is inclined at 50 degrees to VP. The problem is like this. So before going to solve the problem, read the problem carefully and you have to analyze some things. You have to find out the things from the problem. You have to get the information from the problem. So first thing is which type of lamina is there? So it is a pentagonal lamina. Second, is it resting on HP or is it resting on VP? So in this problem that is resting on horizontal plane. That's why you have to start from horizontal plane. You have to start from horizontal plane. That means when that is resting on horizontal plane, usually we have to start from horizontal plane. After that, is it resting on one of its side or resting on one of its corner? So in this problem that is resting on HP with one of its side, that's why one of its side should be taken on a left side. So for that first you have to take a vertical line equal to 25 mm. You have to construct a pentagon. For pentagon constructions, at a point A, you have to measure 108 degree and equal to the distance 25 mm and mark the point E. Similarly, at a point B, you have to measure 105 degree and equal to 25, you have to mark the point C. Now to find out the point D, equal 25 mm and C as the center, draw an arc. Similarly, from the point E, equal to 25 mm, cut this one. So we'll get a point D. Join this C to D and D to E. So the pentagon will be obtained. First you have to construct a pentagon. When the pentagonal lamina is lying on a horizontal plane, when you see from the top, then the true shape will be obtained. That will be obtained like this. After this, when you see the lamina from the front side, so that will be looks like a straight line. That will be falls on the reference line. So for that you have to project these points in a vertical plane. So the straight line will falls on the reference line. You have to name that point A dash, B dash, C dash, D dash and E dash. Now the point E is on the back side. When the observer is at the front side, the point E is an invisible point. That's why you have to put that point E in a bracket. So once this initial position is completed, second position. So for the second position again you have to read the problem. The pentagonal lamina is resting on horizontal plane with one of its sides such that its surface is inclined at 40 degrees to HP. So you have to measure that 40 degree in a VP. So first you have to mark a point AB on this reference line. First you have to select a point AB and its surface is inclined. When this point D is rotated in the upward direction, once the surface is inclined at 40 degree, you have to stop. So for that, mark a point A dash B dash and measure the angle 40 degree and equal to the distance A to D. You have to mark here. Again, measure the distance. That means you have to find out the point C and E. You have to measure this distance from the point A. You have to mark this. So all these points are marked on this inclined line. That means when the lamina is inclined at 40 degrees to HP, then the front will be a line which is inclined at 40 degrees to the reference line x1. So project these points in a horizontal plane. Similarly, take the projection from the left side. The points are obtaining here. The A and A dash will be intersect here. This is the point A. Similarly, B, C, D, and E. So you have to join these points A to B, B to C, C to D, E and E to A. So after joining all these points, we'll get a apparent shape A, B, C, D, E, apparent shape of the pentagon. So once this second position is completed, now come to the third position. So what is the condition given for a third position? So draw the projections of the lamina when the resting side is inclined at an angle of 50 degrees to VP. So you have to measure that 50-degree angle in a HP. So just measure this angle, and which angle the 50-degree angle? Which is the 50-degree angle? Is it a true angle or a apparent angle? So for that you have to read the sentence. The resting side is inclined. Resting side is nothing but line. Line is inclined at an angle of 50 degrees to VP. So the given angle is a true angle. The given angle is a true angle. After that, what you have to place according to the given the condition given the problem, the side AB you have to place. So before going to place this AB on this line, just ask a question. The AB is a true length or apparent length? Now here the length is not changed. This length is also equal to 21. So this AB is a true length. So you have to place this true length on a true angle. That's why you have to use the normal method. So for that normal method, mark a point A, measure the distance AB, mark this. So we'll get a point B. Find this point on this side and draw this line perpendicular to AB and measure this distance, mark here, we'll get a point D point. So with the arcs method, we have to find out the point C and E. So measure this BE from the point B, draw an arc. Measure this D to C from the point D, cut this one. Similarly, we'll get a point on this side, join these points. So same figure is reconstructed on this 50-degree line. After this, you have to project these points in a vertical plane. Take the projections from this side. So similarly take the projections. So according to the procedure, A and A dash will be intersected. Name that point is A dash. Similarly B dash, C dash, D dash and E dash will be obtained. So after marking all the points, you have to join this A to B, B to C, C to D, D to E and E to A. So this is the final position of the figure.